Hello, welcome to a special review issue of the podcast. I'm Rowan Hooper. Welcome to the show. Now, for this episode, I thought we would do a lovely look back on the year. We're going to pat ourselves on the back here for all the brilliant stuff we've done in the year just gone.
Yeah.
Hurrah!
Yes,
Hurrah. Come on. And none of it is down to me at all. So to help me get over the line in this endeavour, I'm joined by my friends and colleagues from the New Scientist Features team, Josh Howgego, Linda Rodriguez-McRobbie and Thomas Luton and Alison George. Welcome to you all.
Thank you.
Hello. What we're going to do is pick out some of our favourite features of the year. Josh, you've been running the features team for much of the year. Are you burnt to a crisp from that?
Well, let's just say I'm looking forward to a bit of a Christmas break.
Diplomacy in action.
Yeah.
Okay, good. So yeah, as I say, we're going to go through the best features of the year, our favourite stories. We're going to add links to all of these in the show notes for people who want to go and read up more about them. And we've got print copies of the mag with us. So let's go round and have your recommendations. Josh, you can kick us off.
Well, I wanted to bring up this feature, which is right from the beginning of 2024, so back in January. And it's all about this kind of wonder fuel, you might call it, which is called gold hydrogen.
I have heard of blue hydrogen and green hydrogen. Why do they come in these different colours? What's gold?
Yeah, it's kind of strange, isn't it? So hydrogen is this really promising environmental fuel because it doesn't produce any like carbon dioxide or any like greenhouse gases.
Yeah.
Exactly. So it's very promising. But kind of the best way to think about it is it's kind of like, rather than being an energy source, it's sort of like an energy store, if that makes sense, because we normally have to make the hydrogen, right? So depending on how you make it and where you get your energy from, that can be like more or less environmentally
right, so you
benign.
could burn coal to make hydrogen.
Exactly.
And then you're in not a good place.
You're not in a good place. Or if you make it, for example, by splitting water and using renewable energy, that's known as like green hydrogen.
Right.
Or like there's grey, there's all different types. Some of it's even made from like natural gas.
Okay.
So, yeah. But gold is very exciting because instead of it just being like a store of energy, the idea is that this gold hydrogen just exists, like it's been made over like the geological eons, and it's just sitting there in the earth.
Yeah.
And we can just kind of drill it up, so we don't have to put any energy in to make it.
Yeah.
It's this kind of, in theory, perfect fuel.
So a giant balloon of hydrogen sounds like we're sitting on top of a massive bomb.
Yeah, it doesn't, when you put it that way, it sort of doesn't sound
and
that
let's
good.
drill into it and get it.
Let's just drill. What could go wrong?
Yeah.
But yeah, I guess to be serious, like we've always known that like there's probably like these geological sources that would make little bits of hydrogen. So we didn't used to think that there would be like lots of it down there that we could just drill up and use for practical purposes. But kind of gradually over, I guess if you go back like a decade, there was this key discovery in Mali, where they discovered under this little town like quite a large sort of repository of this hydrogen. And so over the last decade there's been this sort of increasing interest to see if we can kind of prospect for hydrogen. We've started to find little pockets of it all over the world. And then in 2022, there was this big important study by the US Geological Society. They kind of modeled all these geological processes. And they came up with this idea that there could be literally trillions of tons of this stuff under the earth. So it could be a really big deal. And this, just to sort of come on to our piece that we did, we sent our reporter, James Deneen, to Oman, to one of these places. So it's a place with these particular iron-rich rocks, and James was able to literally see bubbles of this hydrogen kind of emanating from the ground.
Did he light some to test it? Or, no, probably not wise.
Probably not wise.
No.
No.
The insurance wouldn't have covered that. By the way, James gets some amazing trips over the year. He's had some great trips. I know I'm going off topic, but
but you're right. He's very well known for his exotic trips. Also went to the rainforest this year. So.
Is there enough of, is it going to be extractable economically, and is that all still to be determined?
Yeah, I think that is kind of, we've realised that there is, like, it's not a complete, like, non-starter is where we are. Like, we've started to realise that this hydrogen is there in appreciable quantities. I think what's kind of unclear is still whether it's going to be kind of practically possible. So that's kind of part of what James went to see in Oman. He was kind of talking to researchers who are drilling these kind of test drills, okay, just to sort of see how much is there. And the other idea that they have is that maybe you could do something a little bit akin to fracking. So part of the way that hydrogen is produced in the ground is this reaction with like groundwater. So one idea is, even if there isn't super huge deposits of this hydrogen in the ground, maybe you could inject like high pressure water into the rocks and sort of stimulate the production of hydrogen.
Yeah.
The only problem with that is that like the whole point of this originally was it's just there, and now we're starting to get into like territory of like you've got to put in energy.
Yeah.
Fracking obviously has its own problems that people will be well aware of.
Yes.
So yeah.
Okay. Well, nice potential. And as well as gold hydrogen, we've got volcanic diamonds from you, Josh.
Volcanic diamonds, yeah. So this is a story that has its genesis quite a while ago, because I discovered that there are these things called kimberlite pipes, which are basically these kind of extinct supersonic volcanoes that bring diamonds to the surface. Yeah. And I just had to commission a feature about them.
Yeah, well, thank you, because I guess I assumed that diamonds are made if you compress coal, you get diamonds.
Yeah.
But no, like you say, they come out up this from the mantle, from deep underground, through these special volcanoes. So that's another incredible piece.
Yeah, it is, and we don't really know exactly how diamonds are made. We kind of know that they come from deep in the ground, but the mystery that this piece was exploring was, as I was saying, these kimberlite pipes, these kind of massive volcanoes that sort of come up. And the question at the heart of the piece is why these volcanoes went extinct a really long time ago, and why they haven't sort of kept going. So these things have just sort of stopped going off. But I guess people will have to maybe read the piece if they want to know a bit more about that.
Yeah.
The teaser is that maybe they're not extinct after all.
Wow. So all this talk of gold and diamonds, I've been reading The Hobbit to my daughter recently, and all of this talk is making me think of Smaug's treasure. And this is my very clever link to the next story, which is about Thorin. Alison George is here. It was a bit of a tortured link, but it was kind of working.
You got there in the end.
Ali, you're here to talk about Thorin, but it's not the dwarf, is it? It's the Neanderthal.
Yes, this feature is all about how a cave in France is revealing how the Neanderthals may have died out. And it all hinges on the discovery of a skeleton of a Neanderthal that's named Thorin. This is after the dwarf king in Tolkien's The Hobbit, hence the link. And Thorin's remains are being painstakingly excavated from this cave in France. It's taken more than 8 years, and only half of them is out. But incredibly, DNA could be sequenced from a chip from Thorin's tooth. And so we've got his genome, and it is a he. But this threw up a big mystery. Thorin lived about 50,000 years ago, maybe a bit earlier.
Right.
That makes him one of the sort of last Neanderthals before the species died out. But Thorin's genome wasn't like any of the other Neanderthal genomes that have been sequenced. So this threw up a mystery. And it turns out that this Thorin's lineage, Thorin's group, split from the other Neanderthals about 50,000 years earlier and stayed incredibly isolated ever since. They didn't mix culturally, or they didn't interbreed. So it seems as if the last Neanderthals before they went extinct might have been these really isolated small groups just clinging on, and they really might have died out because they didn't have a big social network like the modern humans, the Homo sapiens who came to Europe did.
Wow. So it's another way of explaining why, or understanding why the Neanderthals did fizzle out, go extinct.
Yeah, I mean, other ideas have been there was a big volcanic explosion, or there was genocide, but actually it just might have been that they just didn't mix enough and were too isolated.
Yeah, I always thought the humans were to blame for they bludgeoned them to death.
Probably did that as well. Yeah.
No, I don't know that that's the case. Just it's lack of sharing of ideas really might have been it.
So I edited this story for Ali, and I really enjoyed it for a lot of reasons. But one of the coolest ones was just this understanding that the thing that gave humans the edge was our sociability, our willingness to share ideas. And I think that's a really cool kind of interesting through line throughout history, that's something that's promoted innovation and promoted growth. I think it was also really cool learning through Ali just how advanced the Neanderthals were. And that was something that I didn't really fully comprehend until working on this piece with Ali.
You mean like the culturally advanced and the technology they had even, and the practices they had, all of those things?
Exactly.
Yeah.
That there was so much happening. You sort of have this perception of Neanderthals as kind of, proto-humans who just weren't that great, which isn't fair or accurate at all.
Yeah.
And that they really were farther along than we had thought, or that I had thought, and that there had to be another reason to contribute to their demise.
And Ali, tell us about the cave where, I don't want to call him Thorin anymore because it's really starting to, I think of them as bands of dwarves and they're not Neanderthal. Tell me about the cave.
Well, this is a fascinating thing too. The cave where Thorin was found is called Grotte Mandrin, or Grotte Mandrin if you're French, I think. Mm-hmm. And it is totally unique because it contains occupations of Neanderthals going back 80,000 years. And then you get this band of Homo sapiens coming in about 50,000 years ago. They're there for a while. Then you get Neanderthals coming back again. That's Thorin's lot. And then the next band of modern humans come in, and that's when Neanderthals go extinct. So you've got this almost time capsule of detail about the toings and froings of people very, very deep in time. And really interesting is that on the cave walls, every time people lived there, they lit a fire and there was a layer of soot on the walls, and then stalagmites or stalagmites form over this layer, and it forms a barcode, and you can almost read the occupations to the year back in time. So you've got this incredible record of detail going back 80,000 years.
Wow. And as you say, they're very carefully studying all sorts of aspects of this cave and the people who live there, aren't they?
Yeah, I mean, it's absolutely painstaking. I spoke to Ludovic Slimak, who's the archaeologist in charge of this excavation, and they've spent 8 years getting Thorin's skeleton out, and only a third of him's come out, I think.
Wow.
And they're literally using tweezers to take every grain of sand out, because all the sand around him and everything will give information about whether he was buried, and it might have what he ate, you name it.
And Ali, you've got another story you want to mention about tinnitus that we did in April. Just tell us about that quickly.
Yeah, so tinnitus is the phantom sounds you might hear in your ear, ringings or whining or screeching. It might sound pretty harmless, but it's really debilitating for the people who have it. And an awful number of adults in particular are affected by this. And this feature is outlining a sort of groundbreaking new understanding of tinnitus and how it's linked to a hidden form of hearing loss. And the phantom sounds are actually the brain's response to this form of hearing loss. It's a kind of hearing loss that wouldn't be picked up in a standard hearing test. It's just certain nerve fibres that are damaged. And the really promising thing about this is it's opening the doors not only to new treatments for tinnitus, but also for forms of deafness too.
I found this fascinating, this story, because I guess you always think tinnitus is some sort of damage. Well, it is a damage, but the ringing sound itself, that being the brain's response, something that the brain is trying to sort of add in to deal with it, is really fascinating. Yeah,
the brain is expecting to have an input and it isn't getting one, so it sort of generates one itself.
Amazing.
Yeah, I always assumed it was something to do with the physical hairs, but this idea that it's nerves and is, as you say, internal to the brain is really, amazing, and hopefully will lead to new cures, I guess.
I always get sort of temporary tinnitus after going to a loud gig and it wears off. But I guess if you go to too many, it doesn't wear off. Then, that's when you get it.
Yeah, in the feature, actually, we open with the story of a man who was a DJ and how he developed tinnitus from just being around music too much. But his is quite a promising story.
Brilliant. Thanks, Ali. Okay, look, Thomas, let's go to you now. Mad physics, for want of a better word, is one of the classic subjects we return to again and again at New Scientist. And as ever, it's been a great year for those sorts of stories. You are responsible for some of these, so do you want to pick out a couple?
Responsible being
we thank you for it, for going through them. What have you got for us?
So this first one is quite a fun story by Miriam Frankel. So really we take this idea that the universe could vanish any moment because of the Higgs boson and sort of run wild with it.
The universe could So that's the starting point. The universe could vanish at any moment.
Exactly. So this
the plug hole. No, well, how can it just vanish?
Like the whole thing, everything.
So it's this idea that goes back to 2012 with the discovery of the Higgs boson. This was the final piece in the standard model of particle physics. And when we measured it at CERN, we found that it's in what's called a metastable state. So the way to think about this is, if you imagine a ball in a little divot in a valley, and if you knock that ball out of the divot, it will roll to the bottom of the valley. Mm-hmm. Now, the Higgs boson can do this because its field is a quantum field. That means that there's this process called quantum tunneling, which means that it can knock out of the divot and roll to the bottom. Now, because the Higgs boson is a bit like a linchpin for all the other particles in our standard model, so if it goes to this lower, more stable state, it has catastrophic knock-on effects for these all the other particles, all the forces that our entire universe relies on. Mm-hmm. So if this happens somewhere in the universe once, it creates this catastrophic bubble that rolls out at the speed of light, destroying everything in its path because it is changing all the masses and all the forces of all the particles that everything depends on. So yeah, it does destroy everything, but not all at once, not in an instant. It's this wave that spreads out.
A rolling wave of annihilation.
Exactly.
So do we think that might have happened, or we know it's happened, or we just expect it might have happened somewhere?
Well, I guess this was the idea that the story was playing on. We know that this is a possibility that could happen, and quite a likely possibility because of what we've measured the Higgs boson to be and what we've measured the other particles in the standard model to be. But we know it hasn't happened yet because we're still here. So it's asking what unknown entities or forces could be keeping the universe as it is, as we see it.
Is it possible that, and please forgive me because my knowledge of physics is really, really rudimentary, but is it possible that this could have happened or could be happening in some very, very distant corner of the universe now? And this bubble is like making its way towards us?
So that is exactly what one of the researchers that Miriam spoke to said, was like, well, this seems a very likely thing to have happened. It could have just happened outside of our visible universe and may just be rolling towards us now.
It's not going to roll in before New Year, right?
Well, I don't think so. We don't, but you really don't know. It could happen in the next second. We literally have no idea.
Would we see anything? Like, would we see anything? How would we know? Like, could we measure whether it's happening?
Another feature. Yeah. The last moments of the universe.
Before. It could be at any moment. So we could really run that any time.
So I don't think they haven't worked out these I don't think they've thought about these finer details yet. Instead, they've been using it to think about. It's our job to speculate. They use it for more precise kind of cosmology. So they use it to think about whether things like primordial black holes or supersymmetric particles could exist, or they also use it to try and filter out. There's many different ideas about what the next big physical theory is. This sort of theory of quantum gravity, and it allows them to maybe start like threshing through some of those ideas.
All right, more to come from that. And there's another story that I want to talk about because as a biologist, I like this one because it's a physicist arguing that there are no objective laws of physics. So tell us about this one.
Yeah, I also really like this one. I feel like sometimes not enough thought is given to the sort of underlying philosophical framework of physical theories. And there's maybe a tendency to just assume that all the equations that physicists work with are all actually biologists as well. I'm afraid to tell you that it's this sort of God's eye view of reality, that there is some like concrete
solid reality
thing out there, and this is the description of it perfectly. But this quantum theorist Daniele Ariti, who I spoke to, he is looking at how quantum theory is telling us that there is no objective reality that is independent of us. Instead, he thinks that things that we think are fundamental, like space and time, are created. We sort of collectively create them together through our different perspectives on the world. And ultimately, this means that the laws of physics don't exist without us. They can't exist without us.
Yeah, I mean, you mentioned perspective, and what I like about this story, and actually all the ones we're talking about today and all the best features, they do give you a new perspective on something, whether it's Neanderthal extinction or the reality of the universe. And you've got another one about quantum consciousness, another favourite. Mash two favourite subjects together, and you get another good one. Quantum consciousness.
Exactly. And like this idea of quantum consciousness, that our experience in some way depends on quantum phenomena. It is accused of that. It's accused of minimising mysteries. It's the idea that consciousness is a mystery. We have no idea really what it is. And quantum mechanics is also a mystery. There's this unknown, like how you get all these quantum possibilities collapsing into a concrete reality. We also have no idea still how that happens. So you smush them together and you say, oh, quantum consciousness.
They must be related.
Yeah, exactly. And so you can see why some people are skeptical, but if it is right, this is an incredible idea. And so I feel I've always had a bit of a soft spot for the researchers who have pursued this for decades now, despite often being lambasted and people really describing this as pseudoscience quite often. And in the past couple of years, there have been some not conclusive, but quite intriguing results. And in this story, we looked at some experiments that are using brain organoids, these balls of neurons, and they apply anesthetics to them. Now, we know anesthetics kind of switch on and off consciousness. So you can apply these different kinds of anesthetics, which have different quantum properties, and then you can see how this affects the activity in these brain organoids. The results are still to be fully replicated, but it does suggest that there is something in this idea of quantum consciousness, perhaps, or at least it's worth exploring further.
Yeah, we've written about brain organoids a lot and other kinds of organoids, like, body on a chip stuff. And it's always been from a biological or, a pharmacological point of view, using it to test those things. But to look at quantum processes is a fantastic, it's a great idea to use this sort of new development. So really interesting.
And also to think about the concepts of consciousness that that are brought up, that are raised by the concept of a brain organoid.
Yeah, exactly. And I think there are dozens and dozens of ideas about what consciousness might be. And with all of them, you kind of need to put your money where your mouth is. And I think this is a case of these researchers with a fairly niche idea saying, look, this is what will happen if consciousness is quantum.
Very cool. Linda, you haven't been with us that long, but you've made a mark already. We're going to come on to one of my favourite stories of the year, actually, in a minute. But first, tell us about the screen time story that you've picked out.
Right. So I've only been here since about August, and while I was interviewing and hopefully, trying to get the role, I spent a lot of time with the magazine. And there was one story in particular that really, really resonated with me, and it was our piece about the truth about screen time. And it was by Mike Marshall, who I now understand is one of our fantastic regular contributors, and I think he just did a really terrific job with this one. For me, I think it was a really good example of what the New Scientist can do well, which is to cut through the kind of popular narrative and bring the scientific context. And this story also really hit me exactly where I live, because I have a 13-year-old boy and a nearly 11-year-old boy. And so screen time is a perpetual source of conflict. Oh my gosh. Yeah. Like, it's between me and my kids, and between my husband and me, and my husband and my kids, and just everybody. We are constantly battling it out over screen time. And so it was really nice to get a story that looked at what we're hearing and tried to actually get to the bottom of that. Because one of the things that, we're perpetually hearing that screen time is bad. Like, whatever it is, it's just bad, right? It's just, recently there was loads of research that seemed to come out pointing to children and teens being way less happy than they've ever been, that this happiness curve, this idea that, we sort of are at our happiest when we're young, And then that describes kind of a U shape where you get to middle age and everything starts to get horrible when you have your own children and your own responsibilities and jobs and things like that. And then once all of that dissipates, you're happy again.
Right.
That this sort of U-shaped curve was being dramatically disrupted by new data showing that teens and children are less happy than they've ever been before. So there's a lot of question about what would have caused that. And researchers like Jonathan Haidt and Jean Twenge have a very clear idea that it is screen time. It is social media. It is the smartphone. It is the new thing that came out in the last 12 years that's really changed how we're reacting.
But how do they separate that out from, say, I don't know, climate change and people's perception? There seems that there are lots of things that young people might be feeling quite worried about.
Right, and that some of this anxiety and some of this depression that we're seeing in people might actually be a reasonable response to actual stressors and things in the environment. And that's certainly one angle on this. I mean, the other is actually examining the data itself. Because one of the things that Mike brought up in this piece is that a lot of these studies don't differentiate what kind of screen time we're talking about. So not all screen time is created equal, of course. But many of these studies sort of lump it all together. So bringing that nuance, bringing that understanding that we can dive deeper and differentiate between, say, reading an article on your phone or, playing Brawl Stars on your phone, which is what my kids do all the time. Or, is Minecraft better than playing, say, Fortnite? Is watching a movie with your family counting as screen time, and should it?
Right.
So there's a lot of nuance that is just sort of erased by this concept of screen time as a sort of universal bad. And I think some of the good takeaways that I got from this piece was that it's much better to have an open conversation with your kids about what they're seeing, what they're interacting with, what they're doing on their screen. Can I
WhatsApp the conversation to them?
Yes. Yeah.
You can read it on their screen.
Yeah. Well, most of the WhatsApps and texts that I get from my son are just, yo, mommy, yo, yo.
Need money.
Yeah.
Same. Linda, as I mentioned, you also edited this story on reversing death.
Yes.
One of my favourite stories of the year. Take us through that a bit.
Now, this is really cool, and I think it touches a little bit in sort of the same territory as consciousness and brain organized, and a little bit. It just kind of, there's a bit of a flavor of there, but this sort of intro to this story, the lead of this story, is that researchers at Yale who 5 years ago were able to more or less reanimate a pig's brain that had been separated from its body and kept at room temperature for more than 4 hours. They were able to bring it back to a level of cellular and metabolic activity. There was, sort of the cortex was pinking up. You could see, it was basically not coming back to life, but coming back to life.
Yeah. But this was like on a lab bench. They weren't creating a zombie pig, presumably.
They were not. They were not creating a zombie pig. There are no zombie pigs. So 5 years ago, they were able to do that with pigs' brains, and now they're able to do the same thing with human brains. Yeah. And the key to this operation is a sort of device that's somewhat similar to a dialysis machine, which essentially sort of takes out a dialysis machine, processes your blood for you, cleans the waste products, puts it back in. This is sort of a similar idea to that, except it's a kind of cocktail that preserves different kinds of brain tissue and functions and things like that, and it protects against the bad effects of bringing reoxygenated blood back into an organ that hasn't had oxygen for a while. And that, as it turns out, and that was, I think, the most interesting thing for me from this story, is that much of the damage that occurs to your body and your brain when you've been deprived of oxygen isn't because of the deprivation itself, but because of the reintroduction of oxygen. So this reperfusion technology is meant to kind of forestall and mitigate the damage that's caused by that.
Yeah.
But obviously, this introduces a ton of ethical and weird questions and things like that. And so I think what's really, really, really important to note is that in the case of the pigs and in the case of the human brains that are being brought back to some level of activity, is that there is no evidence that there's any kind of consciousness at all. There is no electrical activity.
They're sedating them, aren't they, as well, though?
Well,
right? So
that's one of the interesting things.
That's to make sure, in case there would be any glimmers of consciousness,
exactly,
that the person or the pig wouldn't be aware of it.
Yeah, which would be a horrible thing.
Oh, it is.
What
I
would
mean,
your experience of the world be if you were only a brain?
But how do they measure that? Because like you said, we don't know what consciousness is. So how do you know if this pig is certain brain wave, certain patterns of brain activity?
So as far as we know, because, assuming that consciousness is measurable by electrical activity or patterns of electrical activity in the brain, the pigs and humans are not exhibiting that activity at all. But it obviously raises a lot of questions, and one of them is well, they were being sedated. The experiments, at least in the pig's case, and certainly I think with the human's case as well, those experiments were ending after about 6 hours, so there was no possibility of regaining any kind of consciousness, and whatever that might look like. But
the technology is getting better. We're able to do it. Someone could potentially do it, but it's another tool for examining these really deep questions, and even very basic ones like what is death?
Oh yeah.
Where is that? There's no agreement as to where it is and when you can not bring someone back from it.
And I think part of what this technology does, and I think the sort of most relevant near-term application is in bringing people back from the brink of death, people who would be closer to that boundary that we haven't really been able to define accurately, and bringing them back without damage. So some of this technology is being used to design new machines that are able to mitigate some of that damage. So we have ECMO machines, which are designed to kind of take on the functions of both the lung and the heart in people who've had sort of catastrophic illness or injury and can't do that on their own. But there are machines now that go even further. There's one that's called Carl. That is the most advanced resuscitation technology that exists, and it takes on more of those facilities of being able to process the blood of the person who is injured and take on the lung functions and the heart functions, but also introduces some of this reperfusion technology that helps deal with what happens when there's damage from reintroducing blood.
Are there limits to this? Like we've talked about 4 hours, but is the... you can imagine some billionaires perhaps wanting to freeze their bodies and preserve them and reanimate them down. Is that a potential use case, or are we getting too sci-fi now?
I mean, I think it is a bit of sci-fi, but knowing the number of people who'd be interested in being cryogenically frozen, I think it's not without the realm of possibility.
I can think of a few billionaires I would like to put in that in that box now, and then cast them into the future and someone else to deal with.
Naming no names.
No,
I mean, I think one of the big takeaways from this is that people who are, quote, diagnosed as dead now might not do so, might not be in the future.
Yeah, and
that's huge. That's really big.
It is, and we can't get bigger than that here today, so we'll leave it there. What a treasure trove of stories. Thanks for all my guests, Linda, Thomas, Alison and Josh. Thanks to you for listening. Thanks for your support throughout the year. This is the last podcast of the year, but we will be back next year. Next week, in fact, we are having a preview of 2025, so get ready for that. Thanks for listening. Give us all your best reviews, and we'll see you next year. Happy New Year. Bye for now.
Bye.
Bye. Thank you.